Hi, my name is John.
And my name is Alice, and this is Math Videos for Parents. We help you so you can help your kids. Today, we are talking about polynomial division. Now, John, I learned it the long division method, but my understanding is you're going to have a little bit of a shorter method for us, correct?
Correct.
Okay. It would be hard for it to be longer than the way I'm about to do it, to be honest. Okay, so what I'm going to do is I'm looking here at this x, and I'm asking myself, what do I need to multiply x by to end up with 2x to the third? So I'm going to say, well, I need a 2. So I'm going to put it here over the second term, even though I'm eyeing the first term of 2x to the third. I need a 2, and I'm also missing an x squared. And if you are not seeing this yet, just hang in there. Now, 2x squared times this x right here, that's what I'm looking at, is going to give us 2x to the third, which is exactly what we wanted, because I can put 2x to the third right under here. And that's not a coincidence. We designed it so that we would end up with an identical term here. Now I'm going to multiply the 2x squared times I'm going to think of it as a negative 3. So it's going to be negative 6x squared. Now, here's the part that always used to get me when I was learning it. You're subtracting, and I find the easiest way to remember to do that is I'm just going to go through and change the signs. So I'm going to flip all the signs here. 2x to the third is going to become negative. Negative 6x squared is going to become positive, and now it's just easier. 2x to the third minus 2x squared, 2x to the third, is going to be 0. Negative 5x squared plus 6x squared is just going to leave me with x squared. Now I'm going to bring down the next term. I'm going to ask myself, what do I need to multiply x by to get x squared? Well, I need to multiply it by x. So x times x is x squared. X times negative 3 is negative 3x. And again, if this hadn't matched the first terms, then I would have paused because I would have made a mistake. So it's nice to have these little signposts to know that you are on the right track. Something I wish life offered us more often. Now I'm going to go through and change the signs. It's just like that. So now I'm going to end up with negative 5x. I'm going to bring down my 15. And what do I need to multiply x by to get negative 5x? Well, I need a negative 5. So negative 5 times x is negative 5x. So we know we're doing things right. Negative 5 times negative 3 is going to give me positive 15. I'm going to go through and change the signs. That's going to become positive. This one's going to become negative. So I'm left with no remainder. So my answer is 2x squared plus x minus 5. Whew, that's a little bit of an endurance. You got to really focus on every single step, John. So please take us away with synthetic division.
Sure. So the fact that you got no remainder is another way of saying that 2x squared plus x minus 5 is a factor of 2x to the third minus 5x squared minus 8x plus 15. That means if I multiply 2x squared plus x minus 5 by x minus 3, I get exactly 2x to the third minus 5x squared minus 8x plus 15. A lot of times when students are in Algebra 2 or pre-calculus, they'll learn things like the factor theorem, and they'll have to figure out whether or not a given factor is indeed a factor of a polynomial. And the preferred method when it comes to linear factors is called synthetic division. The idea is that we take all of the coefficients of the polynomial that we're given. So in this case, I have 2x to the third, I have negative 5x squared, I have negative 8 on the x, and I have 15 as a constant. So every power is accounted for. If there was a power missing, like if I had no x squared, I'd put a 0 there. I place those all here.
And it has to be in descending order, right?
Correct. Yeah, I have to start with the value in front of x to the third. If I'm dividing by x minus 3, dividing by x minus 3 really means, we're checking to see if 3 is a 0 of that function. And with synthetic division, we work just with numbers and not with variables. So we're going to check to see if 3, when plugged in or evaluated in this function, gives us out an output of 0. The way to do synthetic division is to first drop down your leading coefficient, and then you multiply the number you're testing by that value. 3 times 2 is equal to 6. So the product will then get placed in the next spot. So that was multiplication. And then now going down this column, we add down. -5 plus 6 is equal to 1. And we repeat this process. We now multiply the 1 by 3, just like we did with the 2 and 3. Now we multiply 1 and 3. That gives us 3. And again, we add down the column. -8 plus 3 is equal to 5. And then for the last part, -8 plus 3 is equal to -5. Got to remember how to add correctly. -8 plus 3 is equal to -5. And for the last part, we multiply 3 by -5. That gives us -15. And if I add those values down the column, that gives me an answer of 0. So that means that my remainder is 0, just like we had in your example. And the numbers that I got are really coefficients of a new polynomial, and the new polynomial is 1 degree less. So here I started with x to the third, this was x squared, this was x, and this was just a number. In my answer, I lose 1 off of each. So this 2 really means 2x squared. This 1 really means 1x. And this -5 really is now just a constant. And the reason why we lose 1 is because we just divided by x minus 3. Even though we didn't write it out, all of the letters, behind the scenes, we divided by an x. So we lost an x off of each term. So my final answer is 2x squared plus x minus 5. And all of the numbers that I used, even though it seems like it's a trick, this the 6, the 3, the -15, they all show up in Alice's work, just without the variables attached to them.
John, I can see how this way, the synthetic division is much faster and probably less prone to error. I think the one thing I find for myself a little unnerving is I have my way of checking my work as I'm going with long division, and I don't think you can do that with synthetic division. So it's all the more reason to maybe check your work at the end. You can multiply 2x squared plus x minus 5 times x minus 3 and make sure you've got the original polynomial to begin with, maybe.
Yeah, that's exactly right. And the nice part about this method is that if we're ever dividing by x plus or x minus something, we call those linear binomials. Synthetic division is a much faster way to do it. However, if we're dividing by something of a higher degree, like a quadratic binomial or trinomial, synthetic division is probably not the best way to do it, or it might even be impossible to do it. So in those cases, long division is preferable. And for students who are going to go into a calculus type course or sit for an SAT, they should be exposed to both methods, but also know long division for the more difficult cases.
All right, well, I'm excited to try synthetic division.
All right, let's give it a try.
Okay, so now I'm going to do this division problem with synthetic division. So I'm going to set it up over here. I'm going to write the coefficients in descending order. So I'm going to write a 3 because that's representing 3x to the third. Next, I'm going to write -2. The next thing I notice, though, is there's no x term. So I need to have a placeholder for that. So I'm going to put a 0. And then I'm going to put -150. So next, what I'm going to do is I'm looking here, x minus 4, and I want to put 4 here. It's really, in my opinion, easy to make a sign mistake. But the number that is here, because it's the root, it's not -4, it's 4. Just ask yourself, what could you plug in here to make it go to 0? 4 would make it go to 0. Okay, I'm ready. So I'm going to drop my 3 down. And then I'm going to be multiplying by 4. So I'm just going to underline that with red to keep it easy to spot. 4 times 3 is 12. -2 plus 12 is 10. 4 times 10 is 40. 0 plus 40 is 40. 4 times 40 is 160. -150 plus 160 gives me 10. So the fact that I have a number there means I'm going to have a remainder, which is totally fine. So I actually have my answer now. I'm going to put my x's kind of back in. And as John taught us in the last slide, we start with 1 degree lower for the x term. So this would be 3x squared, because we started with x to the third, plus 10x plus 40. And then I've got a remainder of 10. John, how did I do?
Great. And I like how you pointed out the remainder. We shouldn't expect that when we do these problems that we get a 0 all the time like we did on the first slide. Those problems were set up in such a way that what we were dividing by was a factor. If something is not a factor, we will end up with a remainder of 10. One thing I like to add on is for students sitting for an SAT exam, they would see the problem exactly the way Alice wrote it. They won't see it written in the traditional, with the traditional division set up with the part underneath and the part outside. They'll see it written as a fraction, and they'll have to understand that when you see things written as a fraction, that really means division. And they could very well be asked which of the following of 4 choices is equivalent to this fraction. So they would want to choose the one that not only lists the quotient, but also shows the remainder as the value you get in that remainder spot over what you're dividing by. So either one of these two would be totally acceptable. The bottom one would just show how it would look specifically on an SAT exam. For students taking calculus, they'll often need to use an approach like this as well to be able to integrate functions that are more complicated like this one. So this was a very rich problem, Alice, that you did, and I think it was a really good solution.
Wonderful. I can definitely see the advantages to this approach. Parents, we hope that you find this helpful. And if you have any follow-up questions or problems you'd like to request, don't hesitate to leave us a comment. We would love to help you out.
Agree. Please let us know, drop some comments, and we'll make a video for you. Have a great day.